So to kick it off, this should be a review of Algebra 1. Slope-intercept form is known as y equals mx plus b. Just as a refresher here, m stands for slope, and b stands for the y-intercept. Okay, so those are the two ingredients that are very, very important, as I accidentally erase. So m stands for slope, b is the y-intercept. Notice how the slope is attached to x. Okay, so slope-intercept form. Now this form isn't so great. You know, it's only great if you're given the y-intercept. If you're given a graph, always use this form. Otherwise, if we don't give you the y-intercept, you know, this form really isn't going to help you very much. Okay, the form that's much more versatile is right over here, point-slope form. Point-slope form is great, and its name, well, let's get the equation down, and then its name really, really makes sense. Here is point-slope form. And keep in mind, guys, you're going to, you know, lines are the basis of calculus. So you need to know these two ideas, these equations of lines forever. Like, you know, in calculus, you're going to be finding the equation of a line tangent using this formula. So let's identify what we have going on here. Okay, so it's called point-slope formula. You should be given a point, x1 and y1. So you'd be given that information, and then you'd also be given, or maybe you'd have to find, maybe they give you a second point, you'd have to find the slope. So everything else, this y minus, the equal sign, these parentheses, and the x minus, that information, that structure needs to be in every single one of your formulas. And you'll see more what I mean in the examples that I do in the future pages. But so these names both have meaning. Remember, slope-intercept, are you given the y-intercept and the slope, you'll use this formula. Otherwise, if you're given any other point other than the y-intercept, or even if you're given the y-intercept, point-slope formula is going to be what's going to help you. You're going to plug the point in, and then you're going to pop the slope in, and then use the structure or the skeleton. And I can't stress enough how great the point-slope formula is. So we've got our two forms above, and let's just dive right in. So a line has slope of -3. Okay, so that's m. m is -3. Even when I'm reading, right as I'm reading, I'm writing on it. Okay, so we've got slope -3. Oh, and it passes through a point. Which one wins? Ding, 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 point-slope formula. So let me write out the general point-slope formula. And you should always get in the habit of writing this. The more you write something, you know, the less likely you'll be to forget it. Okay, so now I'm going to start to plug some things in, but I'll even rewrite it first with the structure. You could write all of that down first, and then you just have to pop in place the slope and the point. In place of m, your slope, you'll put a -3. And now we have a point. You've got to be real careful here because you have x1 and y1. And notice the y's get paired together and the x's get paired together. So the y1 is 2 and the x1 is -4. And then you should clean this up. You know, if you subtract a negative, that's the same thing as adding. Okay, so this is your final answer, and you can just set it and forget it. And I'm sure by now, even before this lesson, you might say, well, where did this magical formula come from? All it is the equation. All it is the formula for slope, and all you're doing is cross-multiplying and erasing the little sub-2's on x and y. So maybe you might want to pause the video and try that for a moment. So this example should make perfect sense, and as far as we're concerned, you are done, and you'll be able to do this in calculus. All right, so in this example, example 2, we're asked to kind of do what you would call point testing. We're going to test and see if this point this x1 and this y1, if this point -1, -8 lies on the line from example 1. So I've already written out the line from example 1, and what we're going to do is we're going to test this point. If where there's a y, we'll plug in a -8, and everywhere there's an x, we'll plug in a -1. And what we want to see is, are we going to get a true statement, which would mean that the point does lie on the line, or if when we plug it in we get a false statement, that means that the point does not lie on the line. And it's that easy. So the left-hand side is -10. Clean up each side kind of independent of each other, and you're really going to kind of say, question mark equals, is that equal to the right-hand side? Well, -3, PEMDAS says parentheses, -1 plus 4 makes 3. Does -10 make -9? No. So don't just think you're done with the problem right now. Be sure to answer the question completely. So we should say something like, no, -1, -8 doesn't lie on the line since we have a false statement when we plug in. When we plug in or when we test the point. All right, and then you're done. So plugging in and testing points is a huge idea, hopefully that you remember and really learned in Algebra 1. So now in this question, we're still working off of that equation that we developed in example 1, and they ask us to name 3 other points that lie on the line, meaning what are 3 coordinates, 3 pairings of x and y that make true statements when you plug them in. So the way you can kind of handle a problem like this is just make up a random x and then solve for y. So let's say we have x be 0. We'll solve for y. If x is 0, you'll plug a 0 right in here. So you'll have 0 plus 4 is just 4. So I've rewritten the entire equation. All I did was plug in a 0 for x. And so I'll have y minus 2 equaling -12. Add 2 to both sides. So y is 14. So what is one point that lies on this line? Well, when x is 0, we found that y was 14. And you could plug that in and check, and you will in fact have a true statement. Because we solved everything in the correct manner. So we're really just going to make up an x and find the y that makes the whole statement true. So, I don't know, pick your next favorite x. I don't know, let's let x be -4. You can pick anything you want. We'll rewrite the entire equation again, but in place of x now, we will substitute in a -4. You might be wondering, well, why did he choose -4? Well, -4 plus 4 makes 0, so this will be really nice. I have y minus 2 equals -3, and PEMDAS says we'll do these parentheses, which I said just make 0. 0 times anything is 0. -3 times 0 is just 0. Okay, so y is 2 when x is 4. That's another coordinate pair. When x is -4, we found that when y is 2, we have another point that is on line. We have another true statement. They said name 3 other points. Let's go quickly. So I don't have much room, so I'm just going to do this one out loud really quick. Let's have x be -5. A little bit of mental math for you. You should always show your work, but I'm going to do this really quickly. If I plug a -5 in here, -5 plus 4 makes -1. We'll have a -3 times a -1. That makes a +3. So I'll be at this point right here, and I know I did this quick. If you want, you can do it all out. So then y is 5. When x is -5, y is 5. Here are our 3 points, and you can always check them, and you should get in the habit of checking them. Again, just as a reminder, we made up our x, and then we plugged it in and we got a true y. That means that these are all, in fact, points on the line, on the equation of the line. So in a problem like this, or really any coordinate geometry problem that we give you, a great thing you can do to kind of get started and feel confident on the problem is just writing in x1, y1, and x2, y2 because we're given coordinates. So that kind of gives you access to the problem, and it's a great place to start. So there is one formula that we know that can help us with a problem like this. What I mean by that is there is some formula that incorporates a y2 and a y1 and an x2 and an x1. So if we need to find the equation of the line, well, we know our best friend is point-slope formula. And you know what's funny? We already have not just one point, but 2 points. So all we really need, and all we're going to do, is find the slope in between these 2 points. So we write our x1, y1, x2, y2. And even before I do that, and this will be really helpful, let's just pick a point. Pick one of these. Okay, I choose you. Let's say x is -5, so we'll plug that in. And when y is -1. Okay, so I'm going to even box it. I almost have my final answer. I just need to find the slope. So you have no choice but to just find the slope. y2, remember slope equals, always have everything nicely labeled like this. y2 minus, be careful, y1, x2, make sure you're always going, we chose to go from this point to this point, so y2 minus y1, then go back here, x2 minus x1, our x2 is -5, minus, our x1 is 2. Minus minus turns to plus, keep your eyes peeled for that. And so our slope is -6/7. That's our final answer. They gave us 2 points, so we said, okay, well, we have a point, all we need is a slope, so we plugged in the point, and then we found the slope. Bada bing. Another answer, and I'm just going to do this quickly. Or you could say something like y minus y1 equals the exact same slope, x minus x1. Turn that minus minus into a plus. That's another acceptable answer. Either of these are fine. Good job. Now these 2 problems are for you. You have everything you need from this video to be able to answer these questions completely. And you should be ready for, who knows, you might walk in and this might be a graded warm-up or a quiz, because this stuff is so important and this video is so good and so clear that you need to be able to walk in and be able to do this. If for some reason you can't do these examples, go back and rewatch the video. Rinse, lather, and repeat. So good luck.